Lesson's going to be over how AP chemistry represents chemical reactions. So with AP content, everything is very much a particle perspective. They want to think about what's happening not just at the big level, at that macroscopic level where we can see it, but they also want to be looking at what's happening to the atoms and molecules as a chemical reaction takes place. For me, the best way to do these types of problems is to start with a balanced chemical equation. And then from there, you can use whatever the scenario is that the question gives you, and you can figure out the before and after. And all these questions are going to have to consider limiting and excess reactants. And so a limiting reactant is what controls the reaction. It is going to run out first, and then the excess reactant is what's going to be left over. So this problem is telling us to draw the representation of 6 molecules of hydrogen gas and 6 molecules of oxygen gas completely reacting to form water. So let's start with our balanced equation, then we'll draw our particle perspective. So when it says hydrogen gas, we have to remember our diatomic elements. Hydrogen is a diatomic element, so when it is by itself, it is going to exist as H subscript 2. Remember, we can put in our states of matter, plus oxygen gas. Oxygen is also diatomic, which means whenever it's by itself, when it says it's oxygen gas, it is O subscript 2, also a gas. And it is saying it forms water, H2O. And since it's just saying water, it could be water vapor. It could be more likely going to be liquid water. So when you go to balance it, I need to make my sides equal. So right now I notice that I have only 1 oxygen here and I have 2 here. So I'm going to put a 2 in front of my H2O. And then I also have to put a 2 in for my H2. That gives me 4. 2 times 2, 4 hydrogens. 2 times 2, 4 hydrogen. 2 times an understood 1, 2 oxygens. And I already have 2 oxygens. So this would be 1. Now, in this chemical reaction, what we are saying is it's going to take 2 hydrogens for every 1 oxygen to produce 2 waters. That's how these chemical reactions work. These coefficients are the relative number of moles of how many of these substances need to react to be able to produce that much product. That's where you need to start on these problems, is you have to have a balanced equation. Then it tells us to draw a representation of 6 molecules of hydrogen gas and 6 molecules of oxygen gas. So those are going to be my beginning values. So I'm going to just draw a box for beginning and a box for ending. Now, this is my balanced equation. These are my conditions for this question. So it's saying I actually have 6 of each of my substances. If I look at my coefficients, then I can figure out how many of each thing needs to be present for this reaction to take place, and I can figure out which one is my limiting reactant. So if I have 6 H2s to get from 2 to 6, it is a factor of change of 3. And so 2 times 3 gives me 6. Over here, if I go 1 times 3, it's going to give me 3. And then if this is 2 and this is 2, then if this is 6, this is also 6. Okay? These are the coefficients that would exist if I had 6 molecules of hydrogen, but I also have 6 molecules of oxygen. So here's the deal. When you have a balanced equation, whichever one has a larger coefficient is going to be the one that's used up first, because it's being used up at twice the rate of the other one. And so because of that, hydrogen is my limiting reactant. A shorthand way of doing limiting and excess is LR. And then this is my excess reactant. Limiting reactant is used up. It is going to be used up, and there is no hydrogen left in my product. Excess reactant is left over. I will have some left over in my product. So let's start with our reactants. Let's go ahead and just draw our 6 molecules of hydrogen gas and 6 molecules of oxygen. So for my hydrogen gas, I'm just going to leave them as dark circles, and they're going to be small, and they're going to be two stuck together. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, and 1, 2. So that's 1, 2, 3, 4, 5, 6. For my oxygen, I'm going to leave them as empty circles. They're going to be larger because the atomic radius of oxygen is larger because it has more energy levels than hydrogen. So I'm going to make it slightly larger and empty. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 3, 4, 5, 1, 2. Okay, that's my beginning. For my products, if I start with 6 hydrogens, I also made 6 waters. I'm going to draw water different than I did hydrogen and oxygen. It's going to look like a Mickey Mouse head. You're going to draw it, and it's typically drawn the way that its three-dimensional shape is. So typically you're going to have the one oxygen, and then your Mickey Mouse heads are going to be where the hydrogens are. You'll learn more about the shapes and three-dimensional shapes when you guys cover Unit 3. And so I'm going to make 6 waters. So I'm going to put them, that's too big. It's fine. I'm going to put them down here at the bottom because they're going to be a liquid. So 1, 2. So I got 1, 2. I need 6 total. So 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6. Okay, those are my liquid waters. They're going to be down at the bottom, not really necessarily perfectly shaped because liquids are going to be able to move around and flow past each other, whereas solids are going to be in a very fixed position. But then we got to do our excess. So I only needed 3 of my oxygens. So when I went from here to here, I'm going to mark through these. I'm going to use all of my hydrogens. So I need 1, 2, 3, 4, 5, 6 of my hydrogens. But I only need 3 of my oxygens. So 1, 2, 3. I have 1, 2, 3 oxygens left over. You have to show them in your products. 1, 2, 3. AP is very picky. They want to see that you understand that diatomic elements are going to be drawn as 2 dots next to each other. They typically have these pre-drawn for you, so you just have to recognize which one's hydrogen, which one's oxygen. They would tell you in a problem. They also want to see that you have drawn out your final product correct and you've included any limiting or excess reactants. So let's go ahead and look at the next one. So this is another example. This one is from AP Classroom example. This is nitrogen plus hydrogen yields ammonia. The balanced equation is 1, 3, 2. And so if we look at our reactants, we actually have 3 of each of our reactants. And so we have 3 of our nitrogens. We have 3 of our hydrogens. And we're trying to figure out how many of this is going to be made. Well, I already have 3 hydrogens. So hydrogen is going to be my limiting reactant. I'm going to use it up at a rate of 3 to 1. And this one is my excess reactant. I'm going to use up 1 of them, but I have 3. So when I make my 2 ammonia, which is what they show here, your nitrogen trihydride, they make those 2 ammonia. I'm going to have 2 nitrogens left over, and I know it's nitrogen because they gave me a key for this one. And since it started out as a gas and all these are gases, these are all spread out near the top, and you have each of those. There's another example. This one is just showing you different ways to draw things. So I have CH4 over on the left side. I have both of my oxygens on my left side. And then on my product side, I have CO2 and H2O. AP typically keeps the representation of these particles pretty simplistic. CH4 is about as complicated as they get. They try to keep it to problems that are easier to be able to recognize. They're not going to get into really complicated organic molecules or anything like that. This one says, which of the following particulate diagrams best describes the formation of water vapor from hydrogen gas and oxygen gas in a rigid container at 125 degrees Celsius. So a couple things about terms. This term rigid means it has a fixed volume. So we could just say that this is a 1 liter container. The container does not change size. That means that with that, pressure is not being affected in this scenario. Temperature is at 125. So we're really just trying to figure out changes in state of matter. So it tells me from hydrogen gas and oxygen gas. So I can immediately eliminate 2 of these examples, because if you know what diatomic elements are, you know that hydrogen gas and oxygen gas are diatomic. This does not show them diatomic. This does not show them diatomic in there before. So these pictures are always like before and after, reactants and products. So reactants should be diatomic. So I know that these are options. And then I have water as a product in all of them, so that didn't really help, and it's the same number of waters. So I have 1, 2, 3, 4, 5, 6 waters, and I have 6 waters, but these things are not in the same ratios. So again, for me, what I would recommend doing is really quickly writing out the balanced equation. So we just did it a minute ago. So we have 2H2 plus 1O2 yields 2H2O. So again, this is going to always be my limiting reactant. This is always going to be my excess reactant because I use this up at its rate of 2 to 1. So if I know that I have 1, 2, 3, 4, 5, 6 of my waters, then that means I also had to have 6 of my hydrogens. That is the only way mole ratios work, is if you change that number of moles of product, then that also means that we had to have more reactant. So if I look here, hydrogen's going to be the small one. Oxygen's going to be the big one. I only have 1, 2, 3 oxygen. I have 1, 2, 3, 4, 5, 6 of my hydrogens. Down here, I have 1, 2, 3, 4, 5, 6 of my hydrogen. But this time I also have 1, 2, 3, 4, 5, 6 of my oxygen. So I can't use this information to eliminate either of them. So then I've got to figure out about my oxygen. If the rate is normally 2, 1, 2, then it becomes 6, 3, 6, because 2 times 3 gives me 6, 1 times 3 gives me 3. And so in order for us to have no leftover reactants over here, that means both of these were used up exactly the correct amount, which means we did not have a limiting or an excess reactant. They were used up exactly the same. So it means I have to have 3 oxygens. So I got 1, 2, 3. So the correct answer is this one, because this one would have had 3 oxygens left over as product because I wouldn't have used them all up. And that's it for today's lesson. You guys need to be sure that you're being real careful on these. Most of these problems are multiple choice, but I expect my classes to be able to draw them. If you can draw these correctly, then you can definitely recognize from a multiple choice response the correct answer. And so as you're doing these types of problems, be sure that you're being really careful about the balanced equations and thinking about the ratios and if there is a limiting and an excess reactant.